Physics is around you everywhere you go. Let's take a chance to look at some of the physics behind sports. First, let's look at extreme pogo sticking and how it relates to the conservation of energy. While we watch this boy do a backflip, remember that throughout the scene, the energy of the boy remains constant. For example, during this shot, when his pogo stick is fully compressed, and for an instant he is completely still, all of the energy is contained in elastic potential energy, given by the equation of EPE equals 1/2 kx squared. In this shot, at the top of his arc, most of his energy is contained in gravitational potential energy, which is calculated by the equation GPE equals mass times the gravitational acceleration times height. This next shot, his energy is contained between gravitational potential energy and kinetic energy being the energy of a moving object, which is calculated by the equation KE equals 1/2 mass times velocity squared. Let's send it over to Morgan to talk tennis.
Newton's third law. Newton's third law states when one object applies a force to another, the second object will apply the exact same force to the first object. The tennis racket applies force to the ball, and the ball applies the same amount of force to the racket. The equal and opposite reaction causes the racket to decelerate and the ball to move in the opposite direction.
Let's hear Eric discuss drag racing.
In this drag race, we see the physics of Newton's second law that defines the equation force equals mass times acceleration. In this equation, we can see that a car that weighs more and has a greater acceleration will have a greater force and therefore be able to travel a further distance in a specific time interval. In this scenario, the Lexus LFA, the white car, has a mass of 1,483.2 kilograms and accelerates to 60 miles per hour in 3.2 seconds, which translates to an average acceleration of 7 meters per second squared and a total force of 10,382.4 newtons. The Nissan GRT weighs a total of 1,740.5 kilograms and accelerated to 60 miles per hour in 3.5 seconds, which translates to 7.7 meters per second squared and a total force of 13,401.85 newtons. Therefore, the Nissan GTR should win the race. Let's see.
Let's hear Chris talk about curling.
Newton's first law states that an object moving at a constant speed tends to continue moving at a constant speed, and an object at rest tends to stay at rest unless acted on by an unbalanced force. The sport of curling provides a great example for this idea, as the low level of friction between the stones and the ice accentuates this concept. As the curler exerts a force on the hack exerts a force on her, providing the unbalanced force that causes her acceleration, and she is seen speeding up from rest. As her foot leaves the hack and she moves down the ice, the forces acting on her and the stone are balanced, and at this time both move at a constant speed. As the stone slides into the house, it encounters an unbalanced force as it collides with another stone and decelerates to a stop. As the stones sit in the house, the forces acting on them are again balanced,